You know, for decades, computers have totally reshaped our world. But what if I told you a new kind of computer is emerging? One that doesn't just calculate faster, but actually thinks differently. It doesn't follow our everyday rules. It follows the fundamental rules of the universe itself. This is the world of quantum computing. And believe me, it's poised to change, well, pretty much everything. Let's dive in and see how. Okay, so the core difference, the thing that changes the entire game, boils down to one simple yet powerful idea. Think about it. Your computer, your phone, everything you use right now thinks in a world of or. A switch is either on or off. A bit of data is a 0 or a 1. Simple. But a quantum computer, it lives in the wild, weird world of and. It can be a 0, a 1, and both, all at the exact same time. And that little word, and, makes all the difference. All right, so to really get a handle on what's coming, we've got to first talk about the limits of the computers we already have. Let's explore what it means to go beyond today's computers. Don't get me wrong, our current computers are absolute miracles of engineering. I mean, they can simulate weather patterns, design airplanes, but when you throw certain problems at them, really complex stuff, like figuring out the intricate dance of molecules or mapping out vast financial systems, they just hit a wall. They run out of steam. The complexity just becomes too much, and the whole calculation grinds to a halt. And that's exactly where quantum computing steps in. See, it's not just about building a faster version of what we already have. That's not it at all. It's a totally new way of thinking, a new approach that literally uses the strange, mind-bending rules of quantum mechanics. You know, the physics that describes how atoms and tiny particles behave to process information. So, where does all this incredible power actually come from? Well, it's not about cramming more tiny transistors onto a chip. No, it's about completely rethinking what information is at its most fundamental level. Okay, so instead of a bit, which you've heard of, quantum computers use something called a qubit. And this, right here, is where the magic starts. A classical bit is basically a light switch, right? It's either on or it's off, a 1 or a 0. That's it. A qubit, on the other hand, is more like a dimmer switch. It can be fully on, fully off, and a whole range of possibilities in between. And here's the kicker. It can be all of those things at once. Yeah, that whole being in multiple states at once thing, it has a name. It's called superposition. It's this wild idea that our qubit hasn't really decided if it's a 0 or a 1 until the moment we look at it, until we measure it. Before that measurement, it's just existing in this cloud of all its potential states all at once. And this one property completely revolutionizes how you solve problems. Okay, picture this. Imagine you have to solve a gigantic, impossibly complex maze. A classical computer would do it the slow way. You would try one path, hit a dead end, go back, try another path, hit another dead end. You get the idea. One path at a time. But a quantum computer, thanks to superposition, it can explore every single path simultaneously, all of them, at once. It's almost like it gets a bird's eye view of the entire maze and sees the solution instantly. I mean, that's a level of parallel processing that our current computers can't even begin to dream of. But wait, superposition is only half the story. If you thought that was weird, the next part takes us somewhere even stranger. It's a phenomenon that Albert Einstein himself famously called spooky action at a distance. And that phenomenon is called entanglement. So what you can do is you can link two qubits together in this special quantum way so they become a single system. Their fates are intertwined. What that means is if you measure one of them and find out it's a 0, you instantly know, and I mean instantly, that its entangled partner is a 1. It doesn't matter if that other qubit is in the next room or on the other side of the galaxy. It's a connection that just completely breaks our everyday understanding of how the world works. Now, this might sound like just a weird science trick, but this is the key. This is how a quantum computer gets its insane exponential power. Entanglement isn't just a party trick, it's a resource you can use. It lets all the qubits work together like a single perfectly coordinated team. They become this interconnected web where a change in one ripples through the entire system. And the result is a computational power that doesn't just add up with each new qubit, it multiplies exponentially. Okay, so we have these two incredible, mind-bending tools, superposition and entanglement. What can we actually do with them? I know the concepts can feel a bit abstract, but their real-world applications, wow, they could help us solve some of the biggest, most impossible problems we're facing today. And when we talk about what they can do, the sheer scale of the speed-up is almost impossible to wrap your head around. Take something like designing a new drug. You need to simulate a really complex molecule. For one of our best supercomputers today, that calculation could take. This kind of power just unlocks whole new worlds of possibility. We're talking about things like, designing life-saving drugs atom by atom, or creating brand new materials with properties we've never seen before. We could build climate models that are way more accurate, or optimize incredibly complex financial systems to prevent crashes. These are things we just can't do right now. Now, it's really important to be clear about something. A quantum computer is not going to make your video games run faster. It's not for browsing the web. These are highly specialized tools. Think of them like a Formula One car, not a family sedan. They're built for a very specific type of problem, the kind of problem that's literally impossible for any classical computer to solve, ever. It doesn't matter how big or powerful we make them. So what all of this is telling us is that we are right on the edge of a completely new era in computing. But what does that future really look like for us? Which brings us to the big question, right? The one everyone asks. Does this mean I have to throw out my laptop? Is it going to be replaced? And the answer, which might surprise you, is no. Absolutely not. The future isn't about replacement, it's about partnership. What we're looking at is a hybrid world, where classical computers and quantum computers work together. The quantum machine will tackle the impossibly hard parts of a problem and then hand the results back to a classical computer to do the rest. They're going to be collaborators, not competitors. So, you see, in the end, this whole revolution isn't just about making things faster. It's about possibility. It's about unlocking entirely new avenues of science, and maybe even solving problems we don't even know how to ask yet. It's a reminder that computing isn't just about zeros and ones. It's about learning to speak the language of the universe itself. Because the future, it won't just be faster, it's going to be quantum.